We'll get started. So, good morning and good afternoon or good evening, wherever you might be. Welcome to this World Technology Universities Network online event for World Engineering Day for Sustainable Development 2025. For those of you who aren't familiar with the World Technology Universities Network, we're a network united by a shared commitment to drive inclusive and sustainable innovation in technology, education, and research for the benefit of people and place. Today, we're joined by members to share their work and knowledge in addressing global challenges. The United Nations decided that for this World Engineering Day for 2025, the focus of discussions should be unleashing the power of engineers to advance the Sustainable Development Goals, or the SDGs. Today, we're really pleased to welcome colleagues from member institutions, Ahlia University and University of Bradford, to discuss advancing the SDGs through the Internet of Things for smart and sustainable cities. This session will be chaired by Professor Yousif Albastaki from Ahlia University, and we'll be joined by 4 speakers from Ahlia University and University of Bradford, who will each present their talks before ending the session with a facilitated questions and answers. All attendees are welcome to put any questions to our speakers in the Q&A function on this session. And without any further ado, I'll hand over to Professor Yousif Albastaki, who is chairing today's session and will introduce the event and our first speaker. Over to you.
Thank you. Thank you. Good morning and good afternoon to every one of you. Welcome to this World Engineering Day. As you all know, that the term Internet of Things was coined in 1999 by the computer scientist Kevin Ashton. And since that time, there are countless ways IoT is contributing to sustainability goals across every industry and vertical, from manufacturing to supply chains and transportation. IoT is being used in innovative ways to capture new efficiencies, generate savings, and create a more sustainable world. On the other hand, the concept of smart cities is dramatically changing urban development through the integration of information and communication technology and the Internet of Things. So in this session of our meeting today, we will attempt to explore the role of smart cities in driving sustainable urban development, emphasizing the critical contribution of Internet of Things. So in this session, we'll be listening to 4 distinguished speakers tackling this issue of IoT for smart and sustainable cities. So let us start with welcoming our first speaker, Dr. Ammar Aldallal. He's an associate professor, chairperson of telecommunication engineering and department at Ahlia University. His topic will be optimizing urban water with IoT, a smart solution for sustainable cities. Dr. Ammar, the floor is yours. Please start. May I remind you that you have 15 minutes only, and then we'll give the floor for other speakers to start. Please, Dr. Ammar.
Good morning, everybody. So it's my privilege to be here today as we celebrate World Engineering Day for Sustainable Development 2025 and discuss the role of IoT in shaping smart and sustainable cities. Water is a critical resource, yet increasing urbanization, climate change, and population growth are putting immense pressure on urban water system. As engineers, urban planner, and policymakers, it is our responsibility to find innovative and sustainable solutions to manage water efficiently. Today, I will demonstrate how the Internet of Things can enhance urban sustainability by optimizing water management. I'm going to share my slides with you. So my talk will be titled Optimizing Urban Water with IoT, a smart solution for sustainable cities. I start with some introduction about some statistics and information about the situation of water sustainability. So as you know that water is a finite resource undergoing stress due to climate change and urbanization. Nearly 40,000 of the world population faces water shortages today. IoT can optimize water management with real-time monitoring and data-driven insights. As a global water sustainability status, only 1% of the Earth's fresh water is readily available. 1.1 billion people lack access to safe drinking water. By this year, 2/3 of the global population could live in water-stressed conditions. So this gives us an idea about the current situation. The global water use has been increasing by almost 1% per year for the last 50 years, and water scarcity threatens agriculture, industry, and urban communities. By 2030, global water demand is expected to exceed supply by 40%. So there's a great demand compared to the available. In terms of agriculture and water loss, 30 to 50% of urban water is lost due to leak in outdated infrastructure. Infrastructure and agriculture. In the US, 6 billion gallons of water are lost daily due to pipe leak. So this is a big issue. Smart water networks can detect and fix leak before they become major issue. And here where our systems will fit. Considering the technical challenges in water sustainability, aging infrastructure contributes to non-revenue water loss, about 30 to 50% in some regions. Also, climate variability demands adaptive and resilient water networks. Another problem is the legacy of the system that lack real-time monitoring, which require IoT driving digital transformation. And there's also another gap in the policies that need to standardize IoT water solutions across regions. And I'm going to elaborate about these topics in a minute. In IoT-based smart water networks, now we start with introducing some solutions. Firstly, we can use IoT-enabled SCADA, that's supervisory control and data acquisition system, which provide real-time data-driven decision-making capabilities. As an example, this system being implemented in Dubai, and in Dubai's network, water network, which reduces energy costs by 20% by using AI-driven SCADA water management. And the second solution is to use a smart pipeline which integrates a pressure sensor, acoustic sensors, and AI-driven leak detection. And this will enable to pinpoint the exact leak location and will avoid unnecessary excavation. As an example, this has been implemented in Barcelona's smart water network, which cut the non-revenue water loss by 25% using AI-powered leak detection. And the third solution, we can use a blockchain, which is based on smart contracts that improve water allocation efficiently, in which we apply decentralized and transparent transactions. This will enable to track who is using how much of the water in real time and will provide fair and efficient billings. This was already implemented in Australia, where farmers could buy or sell water rights dynamically via smart contracts, resulting in more efficient water use and better crisis management during drought. The fourth solution is to use a digital twin model, where we implement real-time network simulation. This simulation will help us in three areas. It will help to utilities or authorities to test infrastructure upgrades before real-world implementation. It will help AI-powered demand forecasting. So it will help in forecasting the demand, and also disaster preparedness and crisis response. So all this could be done through the simulation and will help us to take actions or plans accordingly. If we consider the advances advanced IoT technologies for water management. So what are the technologies you can implement using IoT? First of all, you can use Edge AI for real-time analytics and decision-making at remote nodes. Why do we use Edge AI? In Edge AI, the processing and calculations and analysis will be done on the end system, not in the centralized server. So there is local AI processing at the edge, and it is also a faster response time and lower latency since the processing is done at the end device. So the processing will be minimal, and the response will be sent directly to the server that will take action. And due to that, there will be a lower latency. Also, it has energy efficient and cost effective because it will reduce the need of constant cloud communication and also saving bandwidth and energy since only the alert will be sent through this telecommunication to the cloud. The second technology you can implement is LP1, that is low power wide area networks for IoT-based sensor connectivity in large-scale networks. The advantage of low power wide area network is that it uses the batteries are long life from 5 to 10 years, and also it covers long range from 10 to 40 kilometers. This technology already implemented in France. They deployed this technology for based water meters and results in reducing water wastage by 30% in urban areas. The third technology we can implement is the cyber physical systems that integrates 5G, IoT, and AI for autonomous water regulation. As an example, a smart valve in a water plant can be remotely controlled within milliseconds to prevent flooding. While the fourth technology is distributed ledger technology for secure, auditable water transactions, in which a blockchain is being implemented here, and it will ensure secure, transparent, and automated water transactions. If we talk about predictive maintenance using IoT sensors, so IoT sensors can be used in maintenance. So machine learning models will analyze the pressure fluctuations to predict pipe failures. So depending on this analysis, there is in fact a great relation between IoT and machine learning, in which IoT will collect the data and machine learning will analyze this data and provide decisions accordingly. Also, AI-driven anomaly detection identifies deviations in water flow patterns. So you can also analyze the water flow patterns, and based on that, you can identify the deviations. There is a flow maybe, so you can take actions accordingly. The third technology here is the edge computing processing, which I already talked about it. So it provides a real-time processing for the data and will reduce latency and fault detection. The other aspect is the water quality monitoring system. So we need to implement smart water quality, in which IoT enabled chemical and biological sensors to detect contaminant in water. So this is another area for monitoring water, where we're going to monitor the contaminant. Smart treatment plants adjust purification protocols dynamically, and AI-driven anomaly detection prevents microbial outbreaks in supply systems. You can make sure that our water is pure. Cloud-based dashboards will provide regularity bodies with real-time quality data. So the dashboard across the cloud-based will provide the regularity bodies with the readings through different sensors and will take actions. There is one more important concept and concern about cybersecurity in IoT water systems. We know that IoT is always vulnerable for cyber attacks. So we need to take care about this concept. IoT water networks are vulnerable to cyber threats like distributed denial of service attacks and also sensor spoofing. So the sensors can be spoofed by the attackers and monitor whatever is there, and they maybe can do their type of attacks. For that, we need to implement end-to-end encryption that ensures secure data transmission across IoT devices. So we need to encrypt the data at the sensor side and also decrypt it at the receiver side, at the server or whatever IoT analysis system. AI-driven threat detection identifies network anomaly in SCADA system. So also threat detection we need to be implemented, and this will allow us to identify any anomalies in the systems in terms of transactions or in terms of attacks. As a case study or example, securing water treatment facilities use blockchain authentication. So we can implement blockchain authentication to achieve this. It will eliminate a centralized point of failure due to this encryption. To securing IoT sensor data, since they are encrypted in the transmission, and it will enforce automated security protocols. So blockchain authentication is very important to be implemented alongside with IoT water systems. Another concern is to integrate IoT with geographical information systems for water management. So we need to, a geographical information system need to be enabled along, to enable real-time spatial analysis of water resources that will allow us to identify the exact location for whatever action we need to take or the location of malfunctions happens. IoT sensors feed GIS models for dynamic water distribution optimization, so it will help us in water optimization distribution. Remote sensing combined with IoT enhances the fluid prediction models. This is very important to predict the amount of fluid so we can control the valves accordingly. As a case study or example, GIS-based IoT monitoring in Singapore's water conservation strategy. So in Singapore, they implemented this type of technology, and they are used to visualize three things: water distribution patterns across urban districts, so it can control and predict the amount of water for each urban area. Also, leak hotspots, allowing proactive maintenance, so they can predict the locations of the leak, so you can fix that and maintain that position or their pipes. Also, they use it for water demand trends, enabling dynamic supply adjustment. So it will adjust the supply for each urban area according to its demands. Before last, if we talk about future of IT and water infrastructure, I still have 2 minutes. Shall I in time?
Yes, 2 minutes, yes.
Digital twin technology for real-time simulation for entire water distribution networks. We need to implement the twin technology that we use the simulation, so we can implement this. Also, we can implement a quantum computing for optimization of water distribution models. We need this to enhance the computation analysis. AI-powered desalination plants using energy-efficient IoT-derived control mechanism, 5G and other techniques. IoT and 5G enable autonomous water infrastructure for self-regulating supply chain. Lastly, I'll talk about the policies. So there need to have some of policies, but because of the time, I'll jump to the conclusion and call to action. IoT is revolutionizing water infrastructure with real-time monitoring and AI-driven optimization. Engineers must focus on designing resilient cyber-secure IoT systems for water sustainability. Policymakers should create robust regulatory framework for IoT-enabled water governance. Finally, investing in IoT-driven smart water networks will secure sustainable urban development. And thank you.
Thank you, Dr. Ammar Aldallal. Dr. Ammar, thank you very much for this interesting topic. If I might say that water scarcity is a big issue in the entire world, but if you come back to our area in this part of the world, these technologies are very important, as the most of the countries in this part of the world depends on water from the sea through desalinations, and it is really costly. So adding these technologies might help and manage these issues. Thank you very much, ladies and gentlemen, our distinguished guests. On behalf of all of you, we thank Dr. Ammar for his presentation. Thank you very much, Dr. Ammar. We leave the question for the end of all the sessions. If anyone has a question, we'll leave it for the end of the other sessions. Now let's welcome Dr. Khaled Ramadan. He's an assistant professor at Ahlia University. He will be presenting a topic, 5G powered smart cities transforming urban life. The speakers, please do accept my apologies. I did not read your entire bio, just to briefly mention your bios. This is mainly due to time limitation. Dr. Khaled, the floor is yours.
Never mind. Thank you, Dr. Yousif. Thank you. Is the share appears now?
Just appeared.
Okay,
yes.
Thank you. Hello, everyone, and welcome to this exciting session about 5G powered smart cities transforming urban life. Okay. The outlines of this presentation can be summarized into 3 points. The first is what's a 5G. The second is the journey of 5G, and the third is the application available in the 5th generation. So first, what's the 5G? In these days, 5G is industry buzzword. Even doctors, teachers, and other people all will benefit from 5G. So everyone should have a fundamental understanding of 5th generation and its application. So the question to ask is 5G just a high-speed internet connection? The answer is no. It's just one aspect. There is no just a high-speed internet connection. In 5G wireless technology, it provides ultra-high data speed with around 10 gigabit per second, ultra-low latency of 1 millisecond, massive network capacity of 1 million devices connected per kilometer square. So 5G is much more than simply high-speed internet access. So 5G provide share information. You can share data, share voice, share video. So 5G is going to be game changer like internet. So brief overview of the 5th generation journey. In the 1st generation in 1980, it designed for analog communication with just audio calls. In the 2nd generation, it provides messaging transmission. 3rd generation with data browsing. 4th generation provide high definition video. While in the 5th generation, we have very important 3 aspects. The first is the data rate up to 10 gigabit per second. The second is the delay with lower than 1 millisecond, and the connectivity of 1 million devices per kilometer square. So what are the regulatory authorities of the 5th generation? Really, regulatory authorities of the 5th generation are responsible for what should 5G be, what should 5G offer, the standards, the available spectrums of the 5th generation. So we have 2 main authorities of the 5th generation. The first is the International Telecommunication Union, ITU, and the second is the 3rd generation partnership project. Really, ITU or International Telecommunication Union is responsible for defining the KPI, network KPIs. KPIs means key performance indicators for latency, connections, and bandwidth. The second is the vision of the 5th generation, while the 3rd generation partnership project is responsible for 5G standards. So global companies like Nokia, Samsung, Huawei, Ericsson, Qualcomm will invest in the 5th generation due to everyone will benefit from 5G. So these companies are combined to collaborate for improving and improving the system towards 5G by evaluating the key performance parameters. So IMT 2020 is the technical name of the 5th generation. Visioned by ITU, we have three main performance metrics of interest. The ITU for the ITU vision. The first is the enhanced mobile broadband with a speed of 10 gigabit per second. The second is the massive machine type communication of 1 million devices per kilometer squared. The question is, are we have the ability to connect to 1 million devices per kilometer squared? When we are speaking about devices, this is not user equipment or human. We mean Internet of Things, sensors. So, for example, in automated cars, we have 10 up to 20,000 sensors in the cars. The third parameter is the ultra reliable low latency communication with around 1 millisecond. So let's check these three important parameters during the improvement of the smart cities. Really, we have many applications for the 5th generation. Let's discuss just three applications. The first is the remote healthcare and telemedicine. The second is the smart building management. And the third is the smart traffic management. Okay, so in the case of remote healthcare and the time telemedicine, live streaming live definition video for remote surgery. So the surgery will use virtual reality. As we know, the virtual reality will be the next social platform. So it needs high data rate. So in terms of enhanced mobile broadband, the enhanced mobile broadband with high-speed data transmission, doctors can perform the operation remotely using a high-definition video with the help of virtual reality. Okay, so this will result in enhancing the accessibility in smart cities, especially in underserved areas. With respect to massive machine type communication, this facilitates the deployment of large number of connected medical devices like wearable health monitors and IoT-enabled diagnostic tools and smart hospital equipment. This will be very useful in remote healthcare. With respect to smart building management, real-time monitoring of building like lighting, HVAC, security, smart building will be very useful by the help of the 5th generation. So in terms of enhanced mobile broadband, this facilitates the transmission of data from IoT sensors throughout the network for things like temperature regulation, lighting control, security servers. This enables better energy management, sustainability, and cost saving in smart building. With respect to massive machine type communication, this supports larger scale deployment for IoT sensors and connected devices in a smart building. The last application for the 5th generation in this presentation is a smart traffic management. Okay, so a real-time video surveillance and the monitoring of traffic flow using a high-definition cameras. So with respect to enhanced mobile broadband, enhanced mobile broadbands provide high bandwidth support to the transmission of large volume of high resolution videos. Okay, so the car may be update the route of the route based on the congestion and other aspects. With respect to massive machine type communication, this allows the connectivity of a huge number of IoT devices, like in smart cars or automated driving. This needs with around 20,000 sensors or sensors in the car. Okay, so now let's check the importance of ultra reliable low latency communication in automated driving in terms of safety. So the vision of ITU supports or say that the ultra reliable low latency communication should be with around 1 millisecond. Okay, so let's assume that we have a car with a speed of 120 kilometers per hour, and let's check the system delay of various mobile communication. In the case of third generation, the typical delay or latency is 100 milliseconds. In the fourth generation, it's about 50 milliseconds. While in the fifth generation, and the recommendation of the ITU is just 1 millisecond. So if this car faces an obstacle and should to stop to avoid an accident, so the sensor collect the data and transmit this data to the system, and the system gives a command or an order to the car to stop. So this process will take about increase the brake distance or excess in the displacement of 333 centimeter in the case of third generation, reduced in the fourth generation to 167 centimeter, while in the fifth generation it reduced to just 3 centimeters. So automatic driving requires extremely low latency due to safety reasons. So we can say that the three main aspects of enhanced mobile broadband of 10 gigabit per second, ultra reliable low latency communication of 1 millisecond, massive machine type communication of 1 million devices connected per kilometer squared. Combining these aspects create an efficient, connected, and intelligent smart cities. And thank you.
Thank you. Thank you very much, Dr. Khaled Ramadan. First of all, thank you for sticking to the time. Secondly, thank you for this interesting topic. Thank you very much. Ladies and gentlemen, allow us to move to the third speaker, Dr. Ahmed Jedidi, the Dean of College of Engineering at Ahlia University. He will be presenting the topic of his presentation is IoT for intelligent transports and logistics in smart cities. Dr. Ahmed, the floor is yours.
Thank you, Professor Albastaki, for the presentation. Allow me to share my presentation, please. I hope it's okay. Fine.
Yep. Yes.
Okay, great. Today, my presentation will present the IoT for intelligent, transparent logistics in smart city, because as we know, come on. Okay. As we know, transparent logistics sector is the backbone of the economy development. We cannot live without this sector. We cannot grow. We cannot do anything. The economy, our life, our everything around us, it's based on transparent logistics. For the transparent logistics before, it's a really traditional way, but with the development of the technology, and it's one of the main sector in a smart city. Mostly when we take the smart city for part not only for individual but for the economy of the country. For this today, I will give you some cases that how to integrate this technology or IoT to the transparent logistics, mostly starting from the sensors until to cloud or to end users. We will use the different steps from the sensor hardware part to the communication, as Dr. Khaled said, 5G until the cloud edge computing, as said Dr. Ammar, and cloud. Okay. What we have as technology, where we are driving technology. First of all, if we will take the data, then the logistic industry really based on the data. They need all the different data collected and is driven based on this. Then they give you a potential for big data to improve operation, and this is it's essential in to drive this industry. To collect this data, we need most of all many parts. Let's go. When we collect this data, we need analytic and automation. Then we will use the artificial intelligence and machine learning and the different technology to analyze and to give smart dashboard to give for the decision makers a clear analysis and data to take their decisions. And also for the management, in order to gain valuable insight about entire ecosystem, the data must be converted into common format. For this, we need, as I said, smart dashboard for anyone who can understand. I can use it for this part. And also, finally, the connectivity when we talk to the communication. Then here, this technology, it's IoT now. IoT, the question for me, it's artificial intelligence. It's under IoT or IoT under artificial intelligence. For my side, IoT is the big umbrella. Artificial intelligence, AI, it's under the umbrella of IoT, because IoT, it's a concept, it's not a technology, it's a concept that we can start from the sensor, from the device to the cloud. All this path is the IoT. For me, I will take this different user case in transparent logistics. Why I choose these topics in transparent logistics? Because in Ahlia, we run now a program, a new program, name in master. Its name, it's Intelligent Transparent Logistics Master in Intelligent and Transport System. And what we see here in region, in GCC, Saudi Arabia, Bahrain, everywhere, Dubai, etc., the mega projects, it's based on the transparent logistics sector. Then we can have this user case, then use the IoT, for example, connect traffic infrastructure, real-time routing and optimization for delivery. Now for the automated last 100-yard delivery, when we talk about drones, predictive maintenance for field, advanced driver assistance when we talk about automated car, information for public transport to synchronize the different parts to give more service and comfort for the user, and automatic vehicle software updates. All this we can use it to use for example, for Dr. Khaled, he said it's the 5G. It's because the latency and the bandwidth, essential for the latency, the bandwidth. And I will select now the connect traffic car. Then the traffic infrastructure, I will talk about general concept, and I will go to Bahrain case. Then we have here more than 1.2 billion car in the road today, and this is set up to be double to 2025. Then we need the new roads being built, but with this increase, when you build the new roads, it's a big size, but still we have congestion in traffic. The ever increased level of traffic will place pressure on existing road network, and we cannot. Then to connect traffic infrastructure can play really big role to make the flow of the traffic more easier for us and fluent. Mostly when we take the case of Bahrain, because the infrastructure in Bahrain, we are islands, and island it's combined with small islands, or it's connected with bridges, and we have more traffic light than highways. For this, the connection they use here, the communication between the part that we communicate the different traffic light together. Bahrain start with to connect this traffic light, but they use fiber optic. When we make discussion with the Ministry of Work, why you use fiber optic, why you don't use 5G? It's easy to implement, and we have with this communication, it's easy. They said really a point that case that when we have official person, he go through the road, and the jammer, he will close the traffic and he make the problem for the signal. He will shut down the signal, and this is they cause a problem for this. They go to the fiber optic to connect the different traffic light in Bahrain. But if we can take general case, the 5G can use easy implements between the different traffic intersections, and they give the ability for the people to synchronize the different traffic light through the road, and for the emergency service, for the public transport, and for the driver, he give more efficiency in terms of time. And believe me, they reduce. Then when we go to smart traffic light, they will make it optimized for the flow and help deal with the accident. We can make deal more with the accident, and longer term analyze of road network. They analyze of road, can determine which are most heavily used and how they are used, and we can find solution. For the public transport, data can be used to help public transport to run on time, factors such as weather, accident, etc. And for the smart road sign, and it's very important for the smart because the weather change dramatically, and here the speed he can change. Also, we have smart road sign. If we have problem or accident or road it's blocked, you can this sign change automatically to give sign for the driver to change the road or take another way, and to reduce the congestion or the traffic problem in the future. And overall, this he can give us a benefits. Why it's benefit? Because connect traffic infrastructure, increase global productivity. In terms of productivity, if me, I will go to my work, I will take 30 minutes. It's not like I will go to my work, I will take 1 hour. It's different, and the road he will take only 20 minutes. Why? With the congestion I will take 1 hour. It's affect my productivity later on in my work, in my physical healthy and moral healthy. Also, they decrease traffic accidents and reduce the amount of fuel consumed globally. Then really it's benefit for the government and benefit for the person and for the society in 3 levels. It's important for the sustainability and for the smart city. Okay, another case we can be helpful for us mostly because now we see that we have online shopping. It's now the star. Now all the big companies, small company, whatever, they will go to the online shopping or the online markets. And with real-time routing and optimization for the industry, he can go from the warehouse to the shop or to the end users with optimized part, and this is benefits. You can track, we can see if for example, your product is sensitive in temperature, we can follow the temperature or the humidity of this part based on the IoT, the communication, you can collect the data easier from the warehouse or from the factory to the end user, and they give optimization in terms of road, and this is also its benefit for the customer, for the individual user, or from the high level of company or part. Then what we can take it in advantage if we optimize or use the IoT here in the real-time routing and optimization. They decrease in distance driven. Then by constantly updating the road and schedule in real time, to ensure it's is in the most efficiency. The total distance driven by each vehicle will decrease by estimated 5%. And it's very important in terms of budget. Decrease waiting time and increase efficiency in terms of delivery for things, mostly with the items sensitive for temperature, humidity, or they are special transport cases. This is for these 2 cases I will select. Then, but if we want to implement technology in smart city, we need to go the IoT. We need to summarize all these 5 things in the same time. We need cloud, and for the cloud computing, we can go more. We have here really a big part, and we can open a discussion for the cloud and selection and integration of cloud and how we can use it with IoT. The communication 5G and edge computing, because for the edge computing 5G, yes, they give us latency, reduce low latency, but the edge computing also for the decision, it's need to take decision for the low latency. Artificial intelligence and machine learning to make it more use the data that we collect and to give accuracy in terms of decision. Intelligent fleet management, this is the part for the management in terms of fuel energy, GPS, tracking, etc., automation. And the cybersecurity is another context. And it's very important because we talk about sensitive data in terms of personal data. And this is need really big intense to work. Mostly now we can use blockchain, and we can use also edge computing to enhance the security, because the IoT sensor, it's limited in terms of performance and computing capacity. Finally, we can use a lot we will, just because we have I use in our university, we have collaboration with the Huawei, which we use the different software and hardware, start from the sensor to the cloud with the Huawei technology, that they provide the full solution with the 5G, because Huawei is already one of the big company for the 5G communication. And for the SDGs, if I go to transparent logistics, he can touch 3 levels of SDGs, UN SDGs, 3 for the good health and the well-being, when you reduce the accident in the road, and when we have you take not longer the road, you don't stuck in congestion, you have healthy parts. Also for the decent work and economic growth, when you are nice in your mode, then they have you here productivity. Also sustainable cities and communities, improve public transport system, better air quality in city due to reduce emission, and responsible consumption and production. The 12, more efficiency use of natural resources, reduce food losses along supply chain. Then we can improve in smart city our quality of life, but we need just to employ the right technology in the right place, and to synchronize the different technology together to give the best results. Thank you.
Thank you, Dr. Ahmed. Thank you. You have finished on time. Thank you very much for this interesting topic concerning IoT as the umbrella for artificial intelligence, or artificial intelligence, the umbrella for IoT. We'll keep it for the end to discuss it together. Thank you very much for this interesting topic. Ladies and gentlemen, now it's time for us to move forward for our fourth speaker, Dr. Daniele. He's assistant professor in computer science and program leader of cybersecurity at the University of Bradford. Dr. Daniele, the floor is yours, please.
Thank you, Professor Albastaki. Going to share my screen now. Can you see my screen?
Yes, please.
Okay, so I'm Daniele Scrimieri, associate professor in computer science at the University of Bradford. I'm going to speak about intelligent digital models for community heat networks. So just a quick introduction to my school and what we do. Computer science at Bradford is quite, let's say, important area for our teaching and research in our university. We had very good results in the latest research assessment. 100% of the impact in computer science was rated internationally excellent or world leading. We got some recent investments in our labs and our computer labs. Our graduates, our recent graduates went to work in a very important international, national, also local companies. We offer a wide range of courses in computing that cover general computer science, software engineering, artificial intelligence, and cybersecurity. And I teach in particular computer science, concurrent and distributed systems, and software design and testing. I used to teach as well cybersecurity. Now, intelligent digital models for community heat networks is a recent project that we started, and that's in collaboration with the company. The company is called Switch to Energy. It is a small medium company that is based in Bradford. This is a particular type of knowledge transfer project. So that's a project funded by the government, by Innovate UK, governmental organization. Involves the objective is to transfer knowledge from a university, which is called the knowledge base. In our case, in this project, it is the University of Bradford, the knowledge base, and a company which is Switch to Energy. It is the duration of the project is 30 months. The aim is to develop a digital twin model to simulate the behavior of heat networks. I'll explain very briefly in the next slides what heat network is. With this digital model, we want to optimize the performance of heat networks and enable the transition to net zero. So this is an example of a community heat network. It is a small heat network at the community level. We can have a much bigger heat network. So a heat network is essentially a system to distribute heat across properties or buildings in a, let's say, small limited area. Okay, so here we got a block of flats. There is a central energy center where you got, for example, a gas boiler. You use the gas to produce heat that is distributed across the apartments or the block. What we want to do is to model the system and optimize various parameters about the distribution of the heat in particular, but we can do also something more complex that I'll explain later. So this is in the UK, there aren't really many heat networks, or not very, at least not many that are quite big. This is just a particular example at the level of a building of flats. And here you can measure, clearly, you know, you need to measure, there is a gas meter essentially to measure the gas that you use. But there is also a meter in each property. And that's where the role of T comes in, because we need, you know, sensors, a distributed network of sensors to measure not only the gas, the usage of gas, but also the heat that is produced and used by each property. The heat is used for hot water, also to distribute hot water in radiators, underfloor heating, and so on. This is a much bigger heat network. So this is from some policy document of the Department for Business, Energy and Industrial Strategy of the UK. And here, apart from the size of the network, we can see that you can see that it's not just at the level of a building. There are various buildings, private and public buildings, including hospitals, not just houses or flats, or even retail parks, everything really, in a small local area. And here we can use energy from the grid, from the national grid, but we can also produce energy using various sources of energy, including gas, biomass. Of course, we want to move away from gas, so the idea is to use low carbon energy sources. But you know, the idea, the system is very general, so you can use multiple at the same time, or the different in general sources of energy, including some quite unusual, at least to me, sources of energy. For example, here you can see also London underground, because I think there is you can produce energy from the ventilation system. I'm not sure really how that works. But anyway, the idea, yes, is to handle various different sources of energy that you can use to produce new energy, and also to sell, to distribute it to the grid. And really what we want to do with the project, with a digital twin in general, is to find the right balance between the production of energy, the use of energy coming externally, and the demand for heat in the various properties of buildings. Now, heat networks are crucial for the UK, for the transition to clean energy. And we are actually planning to increase dramatically the number of heat networks in the UK. At the moment, there aren't many. They are concentrated in certain areas around big cities, London in particular. But yeah, not that many in the rest of the UK. So really, we want to increase the distribution of heat networks. And because we want to move away from gas, we want to replace gas with net zero energy sources. In this project, we are going to develop an energy digital twin to model complex community heat networks. When I say community heat networks, I mean, by community, I mean any, let's say, area of any size, really, not just a small community at the level of a block of flats. It can be a small limited area in any city, let's say. With this, we want to support the future system designs of community or heat networks in general. So we want to use a digital twin to simulate designs, but also to model existing designs in order to understand what the best ways to upgrade existing designs or to optimize various parameters. And this is a very useful tool, the digital twins, energy digital twins, to do a sort of verification or even validation of use case scenarios using a form of hardware in the loop testing, where you connect your digital twin with the physical twin, the physical system that you are modeling, that you are optimizing. So an energy digital twin involves, or at least the energy digital twin that we want to develop, involves the use of physics-based and data-driven functional models. And this is quite challenging because integrating physics-based and data-driven functional models is not trivial. There are different types of models. So physics-based means essentially that you use maths, some mathematical models, mathematical representations of the system, the physical system that you want to model, optimize. And these mathematical models are based on certain assumptions which are quite general, and they usually work well, but they're not tailored to specific scenarios, specific systems that you want to model. Therefore, we integrate physics-based models with data-driven models, where you process the data that comes from your physical system, and you make decisions based on that data. So the decisions, let's say, the insight that you get is on a specific system. It is not, about general heat networks in our case. So with this energy digital twin, in particular, we want to process condition monitoring data from various components of the heat network in order to perform predictive failure analysis. So this involves the analysis of data in order to understand when certain components are going to fail, or in other words, to, let's say, predict the lifetime of components, so that you can so that you are ready to perform maintenance or to replace those components, and also to improve the design of future components to improve the lifetime or the overall lifetime of the heat network and the performance as well in general. So here you can see, so the idea of a digital twin is, so I said it is, you can use it for simulation. It is a model of a physical entity, physical system, but it is much more than that, because it is a model in general, but it is a model that is constantly updated using data, using current real-time data, or data that you collect at, let's say, high frequency in a way. So yeah, continuous. So that this involves the process of continuous flows of data. Okay. And use this data to update your models in your digital representation of the physical system, and to get into get an insight into the functioning, to the operations of the physical twin, to see if everything is working correctly as expected at the right levels of performance. And with this insight, you can make decisions in order to optimize the processes that are performed by the physical twin by changing various parameters. In the case of the heat networks, we said we want to balance the use of the generation of energy and the acquisition of energy from the grid, from the national grid, in order to meet the demands of the users. Now, the idea of digital twins, of course, it is not new, and I worked on various other projects in the past involving digital twins, not for smart cities, but in other engineering applications. And the role of IT in the context of digital twins is crucial, because the digital twin is updated using the data coming from the IoT sensors. So you need network of an IT system that generates the data to update your digital twin. But you also need not just sensors, you need also actuators to then change your system and to perform some actions on your system, so that it can be simply
Dr. Daniel,
yes.
May I remind you that you have 2 more minutes, please?
Okay, yes, no problem.
Thank you.
So here I've got just some other examples of digital twins that I worked on in the field of engineering. So this is a digital twin for machining. So machining is a manufacturing process where you make parts by removing material from, let's say, a block of metal. So the digital twin was used to estimate the optimal speed of the cutting tool, because of course you want to remove as much material as possible, but then you need to be careful, because if you go too fast, the surface of your part will not be very smooth, and you can create, because of the vibrations of the tool. And here again, you got a virtual environment that models a physical environment. The physical environment is a machine, in this case, with the cutting tool. And this is another digital twin that I used to inspect parts. So after you manufacture a part, you also need to inspect it in order to make sure that all the dimensions, all the tolerances are correct. Now, going back to smart cities, here I've got just a question, a list of questions and challenges. So we know IT is important, it can be useful, it is fundamental really to the development of sustainable smart cities. and we got all the technologies that we need to build a complex IoT system. But there are some questions about, let's say, from a software perspective, because I work with software, I don't really, build the actual IoT system. So, for example, in terms of architecture of the system, how can we design a scalable IoT system that can grow to meet the future demands? What if we add more sensors or what if we add more properties, more buildings to a heat network? Is our system able to scale up with these additional resources or additional demands? Then another question is where to process the sensor data. That's something that was covered also by other speakers today. You can process the data. You can use edge or fog or cloud computing. So cloud computing, you collect the data in a central place and you do all the processing centrally. But that's not ideal because you want to, let's say, to do this more efficiently, to process the data as close as possible to the edge, to the IoT resources. But the IoT, resources are not necessarily very powerful, so you need to find, the right compromise. Then also some more general questions. So we know that sensor data can be noisy. You can have outliers. There can be missing or consistent data. What can you do about that? If you do AI, if you do machine learning, you need some quality data. Otherwise, if you go to garbage in, you will get garbage out. So you need some proper, techniques to process the data to improve the quality of the data as much as possible. And then, yes, AI, I mentioned AI, I said that we can do machine learning, but is that the only type of AI that we can use in IoT systems? So what about some automated reasoning where you use the data or other models in order to automate certain decision processes with minimal human intervention? And then security, there's also something covered by other speakers. We need to make sure that our IoT systems in our smart cities are secure. We want to protect them from cyber attacks. We don't want, for example, someone to attack our heat network, and we don't want to stay, without heat or problems like that. And yes, that's about it. Thank you very much.
Thank you. Thank you very much, Dr. Daniel. Thank you. It's very interesting. You people are looking for heat network and we are looking for cool network in this part of the world. It's really interesting. Ladies and gentlemen.
Yeah, you can use heat networks also for cooling, to be honest.
Yeah, that's interesting. That's interesting.
Although we call them heat networks, not cooling networks, but yeah.
Thank you very much. Ladies and gentlemen, thank you very much for our four distinguished guests, Dr. Ammar, Dr. Khaled, Dr. Ahmed, and Dr. Daniele. And now we'll leave the floor for questions and answers. If anyone has any question, please kindly, you have the question and answer part. You can post your question. While we are waiting for questions, I might ask Dr. Ammar a question about what he presented today. How we can apply these technologies which you have talked about in our part of the world, where we are facing water scarcity a lot here. So how we can apply all these technologies in our part. Let's take Bahrain, for example.
Yes, Doctor. Thank you for question. Maybe you can look basically in our area for infrastructure. You can monitor the infrastructure, checking for the leaks through applying this IoT technology through the pipelines. And then we can monitor this, and it will be sent to the central authority and will take actions. In fact, we see a lot of leaks here and there, and sometimes it takes time until it is being reported and take actions against. So through these sensors, it will be alerted directly and actions can be taken fast, reducing the waste of water.
Yeah, I think, yeah, now if there is a question, if you have a question, so we're waiting for, yeah, so we're waiting for questions. Dr. Ammar, as you know that in Bahrain particularly, the consumption of water is very high from the public. This is a big issue, although, you know, we get the water from the sea and we desalinate that and we bring it to everybody's house. How to educate the people, I mean, through what you are saying, to educate the people to control the consumptions of water in this part of the world?
Yes, so this is the part which I skipped fast in the last slide that talks about the policy. So the government need to implement the policies to force implementing IoT, for example, at each house, which will monitor the consumption of water, and also apply the machine learning. We will going to evaluate the pattern for that house, and for example, for the private sector, the pattern of consumption of water, and if it monitors that there is some exceed and usage for the water, maybe can send an alert directly through the IoT devices and alert system. So it is based on the policy.
Okay.
Service.
I have a question. It says that how can vulnerability in IoT devices impact water quality and safety? Dr. Ammar, this is a question.
Yes, since the results of the IoT signals will be sent to the central position, they need to take actions. And these actions could be controlling the amount of water flowing to that destination. So maybe attackers can control or send opposite actions and consume or waste usage of water through this valves or electronic valves. Yes.
Thank you, Dr. Ammar. Waiting for any other questions. Anyone like to ask a question? If you don't have,
I will happily ask a question.
Please. Please.
It's a question to all of you, really, but obviously you've all talked about various different ways that IoT can support sustainability. Do you think that big companies and governments are doing enough to invest in this, or could more be done?
Who would like to start answering these questions? Dr. Daniele, will start with you.
Yeah, I can start. Yeah, I can speak about for the UK.
Mm-hmm.
So there is a growing interest in IoT from the government. Not directly about IoT technologies, but really about the applications of IoT. For example, smart cities or heat networks in my case. So yes, there is a growing interest in the benefits and therefore the applications of IoT, but also about the problems related to the technologies. Definitely about AI, there are many new policies in the UK on the usage, safe, ethical usage of AI, which indirectly impacts IoT as well. And in particular about IoT, cybersecurity as well, which again directly impacts IoT. Because we know that many IoT devices are not secure, because security was not a main concern originally, at least in the first, let's say, IoT systems. So yes, growing interest, new policies related to technologies, applications definitely, and also technologies related to IoT. Maybe not strictly about IoT, but definitely in the area of AI and cybersecurity.
Thank you. Anybody else likes to add anything? Dr. Ahmed or anyone else?
Sorry, because I missed the question because I have problem in my teams. I missed the question. What is the question? If can repeat.
Sasson Wright was she asked the question. I'll ask her to kindly repeat the question, please, for Dr. Ahmed.
No problem. So the question was that you've all talked about how IoT can support sustainability, and whether or not you had any thoughts as to whether big companies and governments were doing enough to support this and invest in it.
Okay, in terms of how to, as the government or the big company invest in IoT for the sustainability, Okay, IoT, it's a concept, but if we can take, for example, the 5G. The 5G is the backbone now for the smart city, for the communication. The 5G is still not used. It's used now, it's 10% only, but I think until 2030, the smart city or the use or the implementation in 5G, it will be something essential. No one he will use it, everyone he will use it, and everyone, the company, the government, he will use this part. And I think with the problem of water, the problem of the weather, the climatic changes, the need, the food wastage, all this need action, and this action, it will be use it for the smart city, for the waste of food, how to the recycling part, everything, it will be involved. But I think it's in 2030 we will fill it. Now we start, but we will fill the implementation of this part in terms of government and in terms of big companies. In 2030 we will start really to fill these changes.
Thank you, Dr. Ahmed. I have a question. It's from Sultan Badr, Sabi'i, I guess. He's asking, what is the most effective approach to balancing edge computing and cloud computing in IoT systems for smart cities, considering security, latency, and cost? So
I can answer here. It depends on the application. Smart city, we have a lot of application in smart city. Use the utilization of edge computing. It's based on the application and what you want to, that your edge, he decide which data he will process and decide in these levels. For example, when we talk about automated car, we need really use edge computing. If I go to the healthcare, we need edge computing. The level in healthcare, it's really high level in privacy and security. But when we go to the traffic light, we need when we use general part, the edge computing is not essential in to connect the different traffic light, because we will use to go to the main part. It's in interior minister or the center of part. It's based on the application, what you have, really what we will use. And this is, he defined for you the edge computing and the communication with the edge computing and the cloud, which data he will stack in the edge computing, which data he will go to cloud, and the type of balance. It's based on the case by case, based on the application.
Thank you, Dr. Ahmed. We have another question by Dr. Maha, I guess. The question is, what are the effects of 5G on human health in relation to the main goal of the SDGs? This question goes to Dr. Khaled. And anybody else likes to answer that as well, of course. Dr. Khaled, can you hear us?
Okay. Really, 5G has more benefits related to human security, so it's can be proven in serious health risks. Very important in continuous research and monitoring to ensure safety. So, for example, with respect to remote surgery, the patient not present in the same place of the doctor or the surgery, so the operation can be performed remotely. So it's very useful in terms of safety, and you can choose the most important and the most useful doctor for you to perform this operation. So maybe it's the patient in Bahrain and the doctor in the United Kingdom or any place. So this will be more benefits, but we should to satisfy the three concepts of the ITU.
Thank you, Dr. Khaled. Anybody else likes to add anything or any more questions?
I think, okay, I will just clarify the 5G. The 5G is not, the benefit of the 5G is not for the user that we use our mobile phone. It's not here, the 5G. The 5G is here for the industry and for the application and level of industry. As I said, Dr. Khaled, 4G, because the latency is different. Then the 5G is to communicate with high bandwidth, with low latency, with the performance in terms of the stability of the network, to communicate machine to machine, human to machine, but not the simple user as phone. For this, when I said it's now we will use, for example, 5G only 10% the utilization of the 5G, but this utilization will grow, it will increase fast. And I think in 2030, anyone who cannot, in terms of company or government or application, he not use 5G, he will be out of the market or out of the economy.
Dr. Ahmed, may I ask what is the status of 5G in this part of the world? To what extent it's implemented?
I'm not understand. I will.
What is the status of 5G here now in Bahrain, for example?
In Bahrain, they implement the first of GCC country. They implement 5G, but in terms of utilization of 5G, it's no more than 10%, 15%. If I'm optimistic, it's 15%. If I'm optimistic, really, people they think that 5G is for the mobile phone and data, but it's not.
Yeah.
It's not the case.
Again, the question is posed is what about the diseases caused by 5G? This is a big issue. True. I know. I believe that's not true, but it's a big issue. A lot of people are asking, and mainly sometimes in the media they post these type of questions.
No, it's the same like when we use the first time the internet. Anyone it's against internet, and now everyone is with internet. We cannot live without internet. It's the same concept.
Thank you. Any other questions?
My question now. If you
have a question. Yes, please.
Who is IoT under artificial intelligence or artificial intelligence under IoT umbrella?
Actually, what I wanted to say, Dr. Ahmed, it's very interesting. You brought me back to my roots. I started my career in the College of Engineering. Then currently I'm in the College of Business. The way people look at these issues is very interesting, to be honest. And today I learned a lot. People from College of Engineering, the way are tackling IoT and the business people looking at IoT is totally different. And I don't want to go through that. So that's why when you say that IoT is the umbrella for AI, it struck me a little bit. So I left it for you to talk about it, if you like. If the rest of the people, the rest of the people agree on this, so I'll leave it for them.
For me, the both, it's marketing name. Artificial intelligence, or it's already exists since long time. When we talk about machine learning, deep learning, neural network, etc. This is the technology, but we give him the name to speak, to give little bit part. And the same.
AI coined in 1956, I guess.
Yeah, and the same for
Internet of Things coined in 1999.
But the same for Internet of Things. It's overall the umbrella for the old technology. It's under the umbrella of IoT because it starts from the sensor, the hardware, to the end user in the cloud. It's all we use. All the technology together, they define IoT. This is.
I do understand the point of view of engineers and the point of view of business people. All these people, I really enjoy that. If the organizers allow me to close this session, or if there are any other questions, I'm waiting. If I don't see anyone post any question.
No, I think we're happy to close this session. Before you say your thank yous, Dr. Yousif, I want to thank you for chairing this session, and also to each of our speakers. You were all amazing, and your insights were really, really useful. I'm not a technical person, but I found it really interesting, and I definitely will go away thinking a lot about Internet of Things.
Thank you very much, all of you. Thank you for our distinguished speakers. I learned a lot today, to be honest, and I enjoyed to be part of this session. Thank you very much, Dr. Ammar, Dr. Khaled, Dr. Ahmed, and Dr. Daniele. Thank you. It was a pleasure meeting you, Safran, all of you. Thank you.
Thank you so much. Thank you, everyone.
See you soon.
Thank you, everyone.
Thank you very much.
Thank you.
Thank you, everybody.
Bye-bye. Bye-bye.